Alright, so now we can look at a vector displacement problem with unit vectors. So this problem gives two displacement vectors, d and e, and it wants us to find the magnitude of the displacement 2d minus e. The first thing we're going to want to do is write down our givens, which are the vectors d and e. It's also important to know that these are 3D vectors. As we can see, there's the unit vectors I, j, and k. And so in the diagram here, I just want to show you that I points in the x direction, j points in the y direction, and k points in the z direction. Now that we wrote down our givens, we're going to want to identify what we're solving for. So in this question, we're solving for the magnitude of the displacement 2d minus e. So we're going to set 2d minus e equal to the a vector, and we're looking for the magnitude of this a vector. So this question actually has two steps. The first thing we need to do is find what the a vector is, and then we need to use an equation to find what the magnitude of that vector is. The next logical step is to identify the equations we need to solve. So below is the magnitude equation for a 3D vector, and it's a equals square root x squared plus y squared plus z squared. And I just want to note below that this is kind of analogous to how you get the c value in the Pythagorean theorem, but with a 3D vector instead. So we can see like az goes in the z direction, ax goes in the x direction, and ay goes in the y direction. And if we take the sum of the squares of all three sides, we get the amplitude a. Similar how in the Pythagorean theorem, a squared plus b squared square root equals c. Now the next step would be to solve for the a vector. So we know that the a vector is equal to 2d minus e, but we don't have 2d, we just have d. So to find 2d, we have to multiply the whole d vector by 2. So below we can see how you do that. You have to multiply each part of the d vector by 2. So 2 times 6, 2 times 3, and 2 times 1. And we get the answer down below. So now that we have 2d, we can now find what the a vector is by subtracting 2d minus e. So to do that, we have to subtract the same unit vector values. So what do I mean by that? The i's with the i's, the j's with the j's, the k's with the k's. So it's 12 minus 4, 6 minus negative 5, and then negative 2 minus 8. And that's how we get our answer for the a vector below. So we have the a vector, but remember we're not done. We need the amplitude of the a vector. So we need to use the amplitude equation, which is a equals square root x squared plus y squared plus z squared. So we take the amplitudes from each, which is 8 squared plus 11 squared plus 6 squared, which is 221, and then we take the square root. And so the final answer is 14.87 meters. And below is just a general form of an a vector, the ax I plus ay j plus azk, and that's how we got those values to plug into the equation. But regardless, 14.87 meters is the final answer.